This is a very...
You're on.
All right.
Good morning. My name is Abir Habbal. I'm a managing director with Accenture focused on data and AI. It is with great pleasure today that we will have the session today on Clean AI, Clear Conscious. I'd like to start by introducing our panelists. We have Benedict McIncooney, who is the Chief Policy Advisor with the Tony Blair Institute. We have as well Curtis Northcutt, who is the CEO and co-founder of Clean Lab that focuses on detecting issues with data and working with top Fortune 500 companies. And we have Alex White from Samba Nova joining as well, focused on driving and commercializing data and AI solutions. When we talk about clean AI, we know that training AI systems relies on large data sets, and the source and integrity of these data sets plays a critical role in driving trust and adoption. So in this session, we want to explore what does it mean to tackle this from an ethical angle. Right? How do we make sure data is clean so eventually we can derive AI value and we end up really reaping its benefits in a trustworthy and ethical way without compromising user trust and privacy? So with the panelists today, I will start with Curtis, tackling our first question around data quality. I'm sure a lot of our audience members, the topic of data quality resonates with them, and we know that it's often a critical barrier to producing high-performing AI models. So in your view, what strategies can be employed to ensure that data fed into AI systems is clean and trustworthy? And how does this impact overall performance?
Great. Good to meet everybody. I'm a very tactical speaker, so I will focus on very tactical things you can do. I think ahead of anything I would say, there's a course taught at MIT called Data-Centric AI. I spent quite a long time at MIT myself. It's a good course. It's dcai.csale.mit.edu. But if you just type data-centric AI at MIT, that's a good place to start. The types of things that are in this data quality for AI space are vast. But the main idea is that if you think of an AI model and there's data fed into it and out of it like water, the data going in is what the model's learning from. And then at time of inference, when a self-driving car is viewing the world, the view of the world is the data coming in. And then at time of inference, that means the machine learning model has already been trained, and it's now going to take action. At that moment, you then make a prediction, and that prediction coming out also is in the form of data. If you're a self-driving car, that prediction would tell you how the wheels should turn, whether the gas pedal should be accelerated or not. This is also data. The key idea of data quality for AI is that you want to be able to identify and ideally put guardrails and evaluation criterion around the outputs of things like self-driving cars so that they don't do things that you don't want them to do, like drive off a cliff. We want the same thing for example, financial realm, where you make a prediction on an investment that is, say, a principal of $50 million. And if it takes some auto action, like a stock market prediction, where you would make an automated investment, you would hope that you would not make that automated investment unless you were highly confident that it was going to ideally earn revenue. So what you want is guardrails around the outputs of systems so that they do the things that you intend for them to do. That's on the output side. Then the data quality on the input side is usually called data curation. And data curation is all about how do you find the perfect data set at training time. So this is different than inference time. This is when the AI machine learns from the existing historical data to make a prediction about what it should do in real time later on. And at that moment, it will look at millions, or depends on the data set size, but typically 10,000 to hundreds of millions of data points. And there's a different task to do at that time. At that time, you have one central task, which is how do I get the best data set possible to feed to this machine learning system, this AI system, so that when it looks at that data, it will learn the best how to do its job, which may be to drive a car or make predictions in a stock market, or if it's an AI doctor, to be able to make good right incision if you're an AI surgeon. So at a high level, you've got trust and quality on the outputs of AI systems. That usually takes the form of guardrails or evals in modern LLMs like ChatGPT. And then on the input side, you have data curation, which is all about how do I create the best possible data set that when this machine learning model or AI model learns from data, it learns to be as accurate and as effective as possible. I'll list a few things and then I'll pass it back. So the type of things you do in data curation would be outlier detection, label error detection, and label correction for supervised learning tasks where there are labels. An example of that would be if you are looking at tumors, do you know if this tumor is benign or not? Those are labels. And often data sets where machine learning models and LLMs are learning from data, the labels tend to actually be quite inaccurate. This is a published fact in NeurIPS that the most common benchmark test sets across the field of machine learning, all without exception, have label errors. In some cases, over 10% label errors. Even in the test sets that have been checked by hundreds of thousands of scientists, there are up to 10% label errors. An example of that is the Google QuickDraw dataset, which is a hallmark of classical computer vision. And the point of this is that we are unaware as humans that the data that these machine learning models are training on is actually full of errors. So it's a critical component of training reliable AI models.
Great insight, even in terms of after labeling and curating the data, we might still fall into errors. Now, before we get into data curation, if we look at data acquisition, and Alex, I'll direct this question to you. With all the personal data, IP, and data protection laws in place, we still see organizations scraping online data, even with the risk of a legal backlash. So in your view, from your experience with Sambanova, does the perceived ROI from scraping online data, is it higher than the potential legal backlash?
Abir, thank you. And hello, everybody. I'm glad to be here. Sambanova, if you don't know, is a full stack platform for AI. We offer very fast inference on the best and biggest open source models. So I'm coming at this question from a different perspective to my colleague on my right. And that is, as a service provider, both on cloud or on premise, we really think about data in terms of how fast you can inference, how quickly you can get started. We think that starting something rather than waiting is the most important action you can take. Clearly, ethical use of data is very, very important, and there's clearly a long way to go in terms of clarification, resolution, governance, legality, and policy making that is very different in different countries around the world. But at the same time, organizations, countries, governments are ready to go. So how do you do that? How do you make that a reality? And we think the important factors are the following. First of all, the models that you choose to use should be open source. They should be developed by the community, for the community, with developers in mind across the global landscape. This is the same thing that happened in the client-server era with the emergence of Linux, if you remember that historical fact. We think that open source is going to be the safest use of this technology. And clearly, secondly, for governments and increasingly for more and more organizations who are in regulated markets or in countries where data is not able to leave the country, and we're in one of those countries now, today, you want to be able to do this work in a secure and safe and resilient environment. And that means on-premise, behind your firewall, often in an air-gapped fashion. So you have the best protection whilst you experiment and develop your tools and techniques and ideas around the use of data. And again, the overall emphasis here is get started now, take action now. So we think that, thirdly, the fastest possible inference is going to be the overriding factor. And that is because you need to experiment. You need to go and iterate as fast as you can to try to get to these levels of accuracy, which are very hard to do and take time to do. But if you're doing that in the most efficient way, you're using technology in the most efficient way, you have a lower cost of operation, you can spend more of your available resources and time on recruiting and attending training courses online or at MIT, recruiting the skills and knowledge and the opportunity to head in the right direction from an ethical use of data perspective.
Amazing. Just building on that, Benedict, and from also your policy-making experience, what would help improve transparency in the AI sector without stifling innovation?
Well, thank you, and it's an honor to be here. So Curtis described himself as a tactical man, which I quite liked, but from the policy space, I like to be a practical man as well. So I think for a number of years, we've sort of had these quite high-level conversations about transparency, and I think there's a sort of a deep set of principles which are now embedded across multiple parts of legislation. The EU AI Act has a lot talking about traceability and explainability. The OECD has similar parts based on that. I think these are all very, very important. But I like what Alex said on sort of experimentation as well. And I think, an open source is an element of this as well, where you're beginning to see lots of this now in practice, and we're beginning to sort of see that sort of transparency and how the how, what, and the why that people need to have the trust in the systems beginning to come to play. I think there are some really good examples from companies doing this, including Wave, the autonomous vehicle company, which has its Lingo model, which explains the decisions that those autonomous vehicles are taking to get people up that trust curve, which I think is a really important sort of innovation that the companies can do from their side. I think then from the actual policy side, which is, ensuring that those are embedded with how the companies operate, but at the same time, I think the public sector in and of itself has a sort of a transparency obligation in how it begins to think about this. And the way that I have been thinking about this across the sort of the data curation space, which Curtis mentioned, which is, I think there's a lot of high-value public data that can begin to be created today, which is essentially a public good for innovation in this. And in some ways, this is sort of a different form of transparency, but I think it's a really important thing in how governments get in this mindset. And I think the one thing that I sometimes point back to is things like the UK Biobank with genomic data, which pulls out lots of high-value data, which might need some cleaning, but is actually really of that quality for people in the biotech space to begin to build off of. And I think that sort of partnership between the companies and the public sector in developing these things, and then begin to experiment, iterate, build some solutions, take them out to the public, and then make sure that you're iterating and getting those feedback loops will be how you ultimately build some of that trust in the system. Yeah. And the way we think about this at TBI is there was some very big risks in deploying AI that is not ready and that will make decisions which are bad. I think Curtis named one area I could see huge risks, an AI doctor, but there will be huge innovations happening in the space in the coming years, and that we should begin to think about what that means. I think probably where governments will be more comfortable in this current period is some of the lower level points of automation, which you can, whether that's sort of simple casework or processes, which probably have less risk to the public and probably high reward. But then as those systems improve in their capabilities, what you want to get to is some form of earned autonomy, where people understand how the decisions have been taken, and they feel comfortable with the AI taking more and more as it gets more capable as well. And so I think that's a process of change that governments will need to go through, but they'll need to do that really in deep harmony with the private sector as well.
Amazing. You touched on biotech and healthcare. So indeed, you see that the problem of data acquisition curation is more applicable to some industries versus others?
Yeah, I think if just looking at sort of the government data estate, it's incredibly poor in many, many places. When the COVID pandemic was happening in the UK, for example, you might think the UK is a hugely sophisticated digital infrastructure, but you had no ability to even understand what was happening in your hospitals. They would email in on a Friday afternoon to number 10, our sort of Prime Minister's office, to say this is what's happening. So I think there's still a lot that can happen in the sort of the type of data you want to collect and build the right kind of digital infrastructure. I think in biotech, there's as I said, the biobank is probably the best biomedical research data set in the world, but it's still relatively small,
Yeah.
and it's mostly based on a very particular cohort of people, i.e. people who look like me, and then there's not wider genomic data around the world, and I think there's so much can be done there. I think we're seeing the early days of things like transport data and autonomous vehicles have been going along, and then the breakthroughs that are happening in things like synthetic data will really stimulate this in quite profound ways. But I think if you look across that sort of public sector space, there's the data estate is not good. I think more widely there are obviously elements, particularly that just scraping the entirety of the internet. There is a huge data set to be based on, but I think it's sort of a mindset shift again that governments need to get into, and thinking almost as data as a competitive asset, and thinking about the elements that it can stimulate innovation across the ecosystem beyond just LLMs as well.
Absolutely. One of the main reasons why we're here, we're talking about regulation, is that AI hallucinations happen, right? And this can become a significant issue when we're talking about health and so forth. So, Curtis, what role can trustworthy language models play in detecting, explaining, and adding trust scores to AI outputs to help increase the reliability of these systems?
Yeah. Really appreciated both of your answers, Alex and Ben. The question here is about hallucinations. How many people here have used ChatGPT? Quick show of hands. It's almost everybody. How many people here have used a trustworthy language model, like the TLM? 0. Oh, one hand. Awesome. Great job. So this is a problem. Our company, Clean Lab, is working on solving this problem. But there are LLMs out. TLM is the first one. It's the most used one that wrap around things like ChatGPT and Claude. And what they do is, in addition to just providing an output, they also provide for every single output a trustworthiness score of how likely that is the correct output for the given prompt. And if you just slow down and think about that for a minute, what does that mean? It means that you can take in, say, millions of prompts and get millions of answers and know of those million, what's the best one. And if you could do that, imagine what you could automate. And right now, the biggest problem so I worked at Apple, I worked at Google, I worked with Apple, not at Apple, I worked at Google, I worked at Oculus, I worked with Jan LeCun Fair, if you're familiar with Facebook AI Research. I worked also at Microsoft Research and also at Amazon Research. They all had the same issue. It wasn't LLMs. I worked for some of these companies a long time ago. Some of them were just computer vision or speech models, but they all have this issue. And a great example is a modern device. Most of us here have smartphones, if not all of us. If that device wakes up and it starts listening to you, that's a major policy problem for large tech companies. If it starts recording the things you're saying and then storing that online without your consent, that's a major problem. But they all have things on there, right? Apple has Siri. Google has Hey Google and OK Google, Google Assistant. Amazon has Alexa. And all of these are machine learning models. And now we're in a new era where we give our data and we type our ideas and our prompts and our thoughts into things like ChatGPT and Claude, and then they give us outputs, and we make decisions based on those outputs, both personally and also professionally in business. And sometimes we do it at scale. Sometimes we do it on millions of documents. And the key idea here is that those hallucinations, while the probability may be small in some cases and large in others, have the potential to have dramatic impact, and they're actually fairly solvable. And what part of my job is today with you all is to help you all know that it is something that there's actually very extensive long-term solutions that have been developed to solve this problem. We've been working on this for over 5 years. But the world wasn't aware that it was a problem until just a year ago. So it takes time for the community to recognize that there are solutions for the hallucination problem. And once you know of them, and I highly encourage, if you've faced hallucination issue, to check out the TLM, you can then start to implement strategies. And one such strategy is to have a threshold of confidence, and you only automate workflows if you're above that threshold. If it's below that threshold, you then send the output of an LLM to a human resource for review. And you can imagine how much of the impact on customer service there would be once you just wrap something like the TLM around classical LLMs.
Amazing. You touched on the point of scalability, and we know that security and scalability are essential for deploying enterprise AI solutions. So how can you ensure that AI systems are not only secure but scalable in a way to maintain that confidence and reliability in outputs?
Yeah, there's three things. So first of all, the architecture is critical. If you're using a Postgres database, for example, it only allows 1,300 columns. So don't recommend that. MongoDB is fantastic. It handles all sorts of unstructured data and is basically built for the modern Gen AI era. So that's one. There's a lot of structural components to consider. Also, privacy is a second main one. So if you want something to scale, it has to work in both private and non-private environments. If you're a business, then the word that you'll learn is VPC. That's virtual private cloud. Anytime that we do business with a large enterprise, our work with them always has to be on virtual private cloud. That means no data shared to us, and this isn't particular to us. This is standard for any AI SaaS company. So that's on the, we've talked about sort of the way you've architected your system. We've talked about the privacy side. And then there's also the parallelizable nature of whatever the method you're doing is itself. The way I like to think about that component, sure, there's the algorithmic aspect, which is like, can you actually run this thing on, if you're familiar with RAG, you split documents and data into chunks. You can do those chunks in parallel. But I'll share like a secret with you of one way that we do RAG at 10% the amount of latency as other companies. What we do is every chunk that is fed in, I know this is quite technical, so I appreciate your attention for those who are less familiar, but basically you have AI systems that can immediately become and instantly become context aware and domain dependent without fine tuning by simply showing them a database where they can access all the information about your policies or your company and be able, for a given question, to access that database and then contextualize their answer particular for your company. And this is a way that anybody can have context, domain-dependent AI that works just for them and their use case without having to even train or fine-tune an LLM. It's a brilliant approach. It's being adopted globally, nearly everywhere at major enterprises. And a trick that we use on the latency side to enable scalability is every document or chunk that is fed into our RAG systems that we provide is labeled a priori as a type of document. So for example, if it's a policy document, it's pre-labeled as a policy document. And then when you ask these LLMs a question in real time, we know, oh, this question is a policy question. So instead of searching a massive database, imagine a large company like Apple or Google or Oracle, instead of searching the whole entire database, which is often massive, you only search the subset of the database that is pre-labeled as policy. And this allows you to take your massive search across potentially trillions of data, of gigabytes, terabytes of data, and focus only on the 10% that's about policies. And so that reduces your search time by 10%, which is the largest latency factor in RAG systems. So that's one example of how you can reduce latency. That's like very concrete.
Amazing. You know, getting some insights here in terms of how to impact performance. Alex, going back to you and Sambanova, when it comes to data for AI training, quantity or quality, which is more important in light also of our discussion?
So I think that's an important question for companies wanting to make use of these tools and these resources. It's not something that we specifically think about consciously. What we see is that from an efficiency perspective, things are changing so very rapidly. You know, even a year ago, the prevailing thought seemed to be that monolithic models that took a very long time, a very large amount of money to train, were going to be the only way to differentiate in the marketplace. And it's very clear today that that's not true. And even 7 billion parameter models outperform some of the biggest, shall we say, pre-existing models. Almost sounds prehistoric, but it's only even a few months. And in the last month, we have 405B Llama 3.1 that's been released by Meta, which clearly in the developer community is proving very, very popular. And again, this model is highly efficient, highly effective. So we think that some of the important factors to think about are, first of all, efficiency. How do you do this scale in an efficient manner? Because as well as data ethics concerns, I think another massive concern is how green this technology is going to be in the future. It certainly needs to be greener than it currently is. On the one hand, you could argue that scalability is currently infinite because you have infinite resources on the internet. But unless they're efficient, then it doesn't necessarily scale with your needs and your demands. And back to what I said in my answer to the first question, taking action we think is the most important thing. So when you think about this as a journey, let's pick an example of the self-driving car. Somebody mentioned that earlier. No one would suggest that you, tomorrow in a country in the world where I am the ruler of that country, I decree that from tomorrow everybody will be in self-driving cars. That's clearly not practical, it's not going to work. You're not going to have the trust of the population that that will work. You do it in stages, one step at a time. And we see that these technologies are already proliferating really every new model of vehicle with lane changing capability, with driver assistance, with more efficient use of your time in the car, be that from a social media perspective or other connectivity that the car is capable of. And the same is true, I think, the analogy is that the entire AI journey is analogous to that. You don't want to start with the biggest problem. How do I provide healthcare to citizens and make decisions without the use of a doctor because I have a shortage of doctors? That's not the first thing to start with. There's plenty of safe, very large amounts of safe, unstructured data that can be incredibly efficiently useful in terms of lower level value perhaps, but very much building confidence and trust in the use of these systems. And I think that's the way this will evolve, that you'll achieve in an organization, in a government, in a country, you'll achieve higher levels of trust through repeated high performance and high efficiency use of new technology. And this, I think we would all agree, certainly on this panel, this is a new era that we've entered into. We're really in the first hour of that new era. These eras have been defined by new infrastructure requirements. If you think about the internet, it was a great idea, but it wasn't possible without points of presence. You had to lay the cable under the ocean to make the connectivity that created the ability for the social media that Generation Z exists in. It wasn't possible before. This era will be the same. You look at the stock market performance over the last 5 to 10 years, the fastest growing companies in this space are infrastructure companies. They're providing infrastructure resources to build these new capabilities. I think my answer to your question in summary is the next hour of this new era will be more focused on what is the efficiency of those new resources. Because if you simply continue the way we are in terms of infinite availability of compute on the internet, you start to push the laws of physics. And we're seeing that already in terms of power throughput in these systems. It's simply unsustainable from the point of view of the planet's health, your budget's health, your ability to find the investment to continue to do this. We have to do it more efficiently.
Yeah. You talk about the next hour. Let's talk about the next 3 years. Although, really, I know the possibilities are wide. But I'd like to hear from each of you. What's your view of what's going to come in the coming years when it comes to AI? Maybe Alex.
Well, where will we be in 12 months' time? I think possibly Gain needs to run the conference every 6 months, maybe in different cities to keep it really interesting. But it really is changing faster than 3 years. I think that in the developer community, and we're seeing already, the fact is that if you're starting as an organization, any entity, you're taking action, you're beginning to see some efficiencies from the data sets that you have, albeit quite small data sets. You're probably starting with PDFs, with documents. Well, every entity in the world, those documents contain both text and image. And the text side of things works quite well and universally quite well in these LLM models, but the image side of things is more complicated. So prediction number one, if you like, multimodality is going to become the norm, certainly less than 3 years. And that will spur new innovations and new ideas and new thinking about, okay, now that's possible, where can I go from here? Secondly, I think the domination of the cloud, if you like, in terms of people's consciousness, decision makers' consciousness, and I'm being a little bit cheeky here because it's already happening, but I was saying 12 months ago, I promise you, that I saw a slowdown in the cloud-first policy that most organizations have, because private data needs to remain private, regulated data needs to remain in the regulated zone, sovereign data needs to stay in the country. That doesn't allow the current status quo to continue to exist. So we'll see further investment and countries inviting further investment from hyperscalers to put points of presence that are sovereign, that are secure, but that will take more than 3 years to achieve. It won't be a choice that many people have. And so hybridity is going to become much more normal. Hybrid interoperability between cloud and on-premise. And therefore the interoperability and the, if you like, the composition of that architecture needs to be highly efficient, needs to work easily. That will require new collaboration in the industry, new partnerships, perhaps new companies being formed. Certainly new companies have been formed around governance in this area, which is also going to be very important. So in a way, it's an evolution of where we are, but I think it's happening much more rapidly than 3-year horizon. If I was trying to guess in 3 years, I think there will be some new fundamental breakthrough in terms of killer application. There will be a killer app in the next 3 years that transforms an industry.
We look forward to that.
If I knew what that was, I would tell you, but I don't.
What about you, Curtis? Coming from MIT, CSAIL, what's your future outlook for the coming years?
I think there's 3 questions.
Yeah.
One is, what's the future of technology? One's, what's the future of business? And one's, what's the future of the world and the market? To Alex's point about the cloud era, that started out as a consumer's market. People wanted things to be on the cloud. And then it became a seller's market. So the businesses had the power. They forced cloud on everyone because they eventually they were in a position where they could do so. And then ultimately, some people realized, no, we actually don't want to be on the cloud. It's not as good for us. And it's now settled into both a buyer's and seller's market, with mostly being a seller's market where people try to force cloud on everybody. In AI, we haven't figured out what the market is. So the future is totally unknown, which is very interesting. What are consumers going to demand of AI products? We don't know that yet. And it's the right question to ask, because if you knew the answer to that question, then you would probably make a company that would be worth billions of dollars. So what I'm trying to identify for you are the questions to ask that are the sub-questions of the big question, which is, what is the future? And in the market, I cannot tell you how that's going to end up. I think that it'll most likely be a buyer's market, but then there will be niche areas where it's a seller's market. And from the technology perspective, I had a really interesting conversation with a journalist from the New York Times, and she asked me, do you think that these massive tech companies that have the infrastructure and compute power to train LLMs will end up dominating the business side of Gen AI? So effectively, will Google, Microsoft, et cetera, take all the market share, and there's not really much room? And I completely think no. And I think that's worth considering. I think the future will be not so different than we'll get to technology last. I know that's the most interesting one. But the business one is important because it will determine a lot of the technology. If I can't sell my technology to you because you don't have the business infrastructure, an economic buyer, a champion to actually buy it, it doesn't matter if you want it or not. If you don't have somebody in your company who can do the deal, then it's not going to happen. There has to be budget for it. You have to demand it. You have to know how to pay for it. These are all complicated things in B2B SaaS environments for AI market. So the question to ask then is, as a business globally, as we're trying to get AI to be consumed and we're trying to grow AI, things have to be paid for. How does this all work? And I think you can think about it the way that you can think about electricity and then the internet and then AI. So in electricity, the inventor of electricity did not end up making most of the revenue off of electricity. It was companies like General Electric. It was the appliances and infrastructure. So it was governments and businesses that laid the lines, that put the first cables under the line, then for electricity, then later on for the internet. It was the application layer, which at that time was like vacuum cleaners, dishwashers, consumer electronics. And these are the things that we actually built and invented that people paid for, and then we put a lot of innovation in. And they consumed most of the market share of where the actual money was made on electricity. Later on, we then had the internet era, right? So internet comes out. Did the people who invented the internet end up having that much control over the business economics of the internet? No, they didn't. It was people from Caltech and MIT and the government. The people who ended up making most of the money on the internet ended up being the application layer and the infrastructure layer. So that's Facebook, that's your Google.com. And then on the infrastructure layer, that's CrowdStrike, that's the App Dynamics. It's the companies that ended up Palo Alto Networks, the companies that created the infrastructure that the internet relies on. And I think we'll see the same thing with AI. I don't think it's the companies that own the LLM are going to own all the market share. It's going to be the companies that build the killer app. It's going to be the companies that build applications that are useful to both consumers and businesses, and also the infrastructure companies. What is the future of the infrastructure that ends up being the underlying model that we all build future AI products on top of? That's yet to be determined. I believe it'll be a mixture of both hardware and developer APIs. So it'll be these things where you can spin up an AI feature into your product. Imagine a natural language interface for any product in the world. So you could just talk to a product and it does things for you instead of having to know how to use a product. That is a future that will exist one day. And the way that future will exist is companies like CleanLab, for example, that build developer APIs that enable very quickly engineering teams at businesses to add AI into their product. And I think this will be a major part of the future of AI. And what that looks like, we'll switch to the third part, which is the technology question. I think what the future will look like is the following. I think jobs that are the most automatable will be automated. An example of that would be the SDR, BDR role in sales organizations. That is a very automatable job with modern LLMs already today. And it's just something we have to be aware of. It's going to happen. It's pretty unavoidable. After that is likely marketing. A lot of marketing jobs where you basically take a technical content, something I struggle with. I speak very technically, but then we need to market to the masses. And that process is very, very doable actually with a modern LLM infrastructure. You can take a very technical document, give it a task like make this document more consumable by the masses, give specification of why, and it will produce for you a less technical version of that technical document. And that actually is a human job being done today by a human workforce. So we'll see a escalating series of jobs that are more automated. And then there are the other jobs which are on the creative component. And those will mostly be augmented, not replaced. So an example of that is if I'm a product designer, AI can't fully do product design. It's a mostly creative task and it requires a lot of human intuition. But you can use AI systems in order to enable you to do that job faster and to parse a lot of information. So I think we'll see this increasing amount of jobs replaced. I think we'll see our sort of two places come out, the application layer and the infrastructure layer. I think from the technological perspective, we'll see a future where most LLMs actually have access to data. It'll be controlled. There'll be a lot of emphasis on governance. So who owns access to what data in order for these LLMs to do what they do? And in that world, I think we'll be able to make more informed decisions. I think we'll have context-aware and domain-specific AI, meaning AI for each individual company and person that's good at the things that that company or person wants it to be good at. And I think that's a future we'll get to sooner than later, 3 to 5 years.
We touched on technology, business, market, sustainability. Benedict, over to you. You're out.
Yeah, we've definitely covered a lot here. So, I mean, I actually think one thing on the infrastructure side, which is that, you know, it looks like compute is not becoming the threshold in the coming years, and energy is going to become a huge component of that. So I think a lot of the political conversation will shift to that energy side and actually see, if you get it right, you can see actually a good dual strategy between developing clean tech and AI simultaneously, which is kind of a modern industrial strategy for most enlightened countries, in my view. And then I think, actually related to that, I think some of these companies on the big infrastructure companies will become energy infrastructure companies as well as part of their association, which is, you've already seen Microsoft, Google and others putting huge investments into geothermal, renewables, nuclear, for example. So I think it will be interesting to see how they begin to almost go full stack in a different way on that infrastructure layer. So I think the second point, I really agree on some of the application side as well, and I think you'll begin to see this with, you see it already in Perplexity and Search and Copilot, for example. I think a lot of these tools will become very, very commonplace, not just for sort of consumers, but for people, whether they are in government and for all of us. And I think we'll see some shifts quite dramatically in that. I think the final point then, just to build upon, I genuinely believe in the same way that this will shift industry, in the way that, Netflix, was the winner against Blockbuster, and you just saw these huge transformations. I do think we are going through a similar evolution, and I think a nation state that will begin to sort of reimagine how government itself operates will rise in the same way that Estonia did in the last sort of digital era. Singapore and others have begun to rise, and I think it will offer a new pathway to development for a country. And in the same way that it might not be Google that ships that brilliant frontier product because it's a big incumbent, I think we might see a surprising couple of nations begin to rise up because they've been very proactive in how they adopt AI and rethink how government itself can operate and be smaller, faster, and hopefully with better outcomes as well. So that would be my wild prediction. So, yeah.
Thank you for the great insights. I really love the addition in terms of how some industry boundaries might start to blur as we emerge into this future. Ending basically this panel with the note, clean AI, clear conscious, let's get into this world together. Thank you. Thank you, panelists.
Q&A.
Okay. I think our panelists are excited for some Q&A. Do we have any questions from the audience? Please go ahead.
It's a panel about fostering transparency. My question is about possible limits to transparency. We heard advocacy of open source solutions, but are there cases perhaps when things should not be made open source? After all, scientists are not encouraged to publish details of the smallpox virus. When we find zero-day exploits, we are not encouraged to publish them on the darknet. So should there be perhaps some limits on what happens in open source AI to prevent naive people or possibly malintentioned people from removing the safeguards and making their things go faster, they think, but actually much more dangerously?
So I raised the topic of open source. I think, first of all, I'll give you my answer to that question. You're absolutely right about use of data. We talked about this a little bit on the panel. There are real concerns and traps that you can fall into. My use of the word open source wasn't specifically about the models per se, but about the concept of open source. Open source to me means, in a way, not for profit, for good, for societal good. It's a community, a global community of developers who see the real potential with this technology to do good for humankind, and that certainly covers every industry, but you see that the real leaps forward have already started in medicine. Medicine is one of the first areas to be adopted, if you like, by the development community. And I would argue that safety regulations have already been built into the thinking there, very much, from companies that are for profit that are operating in that area. But scientists, generally speaking, I'm sure the concept of evil scientists existed before films came up with the idea. But in general, scientific work is for good, and it's for the betterment of society. And that's what I meant by open source, this opening of possibilities, collaborating together globally to solve problems, big problems. And again, I feel very good that that is heading in the right direction. And it's represented in a number of different ways, but one of the best ways I can think about, one of my children is just embarking on a PhD. Even 2 decades ago, a PhD was for life. It was your lifetime's work. And we're now in this era seeing the possibility of your PhD vision being achieved in 4 years. That is unbelievable progress for society. Because if you multiply that across all the work that's happening, and some speakers yesterday in the conference, hundreds of millions of proteins being mapped, the Human DNA Project, research across scientific endeavor, this is all going to create a better society for us to live in, I think.
I'd like to ditto the excitement about the future, but I also want to give you a really concrete answer to your question of a very specific example that you could use if, say, you were writing a report about your question. Anonymity is the answer, I think. Specifically, if your data has been trained on and you don't want anyone to know what that data was that was trained on, that's a really interesting question. And right now, it is possible, if you open source the architecture of a model and you just look at the prediction that a model makes, there are certain models that just given the prediction, you can actually exactly find the data point that that model was trained on. And if that data point, say, happens to have your genome, or it happens to have who you've married in the past, or personal information about your relationships, or maybe your education status, and someone gets a hold of that, they could use that against you, and it could be very serious. And so there is a question about if we should actually open source the architecture or the weights of all models. Because if you do, then it does open up the potential of anonymity being retracted, which in many cases is exactly the opposite of what people agreed to when they shared their data in the first place.
Our time is up, unfortunately, but I speak on behalf of our panelists that we'll be happily taking the questions separately. Thank you very much for your attendance.